We are very happy to do our development in collaboration with, in partnership with ChemAxon, relying on a lot of tools they developed in the past. So it's really great to do this. ChemPass has been around for about a year and a half. We are developing technologies for the processing and utilization of forward in silico synthesis. As part of, we're building a software, obviously. So it's a primary cloud-based software, but you can run it on your server or we can host it for you. Part of the technologies is a chemical know-how database and reaction database, which I want to emphasize is not an enumeration tool, so we're not enumerating combinatorial libraries here. We are doing scaffold and analog design. And also a designer module which, based on these rules and know-how, can design a lot of interesting compounds for medicinal chemistry and organic chemistry. It is intended for chemists, medicinal chemists, to some extent computational chemists as well, but the primary client is planned to be medicinal chemists. So it's very simple, very straightforward to use, no cheminformatics knowledge whatsoever. It's fully customizable for any client. So why are we doing this? In practice, any organic chemist will probably use 50 different reactions in its lifetime to assemble molecules. We really go back to the same tools to build compounds. But you can buy about 1 million building blocks. So when you combine these 50 reactions and these building blocks and you apply it 3-4 steps, the overall combinations are incomprehensible by anybody. We've been doing this for a long time, and you always come up with surprises, things you never thought of. If you only use these few reactions and you apply these 1 million building blocks and you try to come up with all these combinations, it's a huge chemical space becoming available. If you add all these other synthetic methodologies, new discoveries, and all the probably around 500 reactions which are described, the space is enormous. So all these new compounds, new analogs, new scaffolds, which are all synthesizable, obviously, at least according to the software, will add to your discovery. So we plan to have our product a very central position where right now we don't think there is any tool which can intelligently utilize all the synthetic knowledge described in Reaxys or e-notebooks, all the available reagents and proprietary reagents of any company, apply the design and subject these design new molecules to SAR or toxicology filters, and the project SAR filters. Obviously, this can feed back as filters, and the compounds will potentially enter docking and other studies. So it's a central engine which connects the synthetic world with the biology and SAR world. And we don't think that you can effectively do this without a reaction-based tool. So a couple of things the software and the technology provides and some features. We're doing chemistries up to 3 steps without final D protection. We can process stereochemistry if we are aware of it. We can process side reactions, so a single reaction can have different outcome depending on the reagents. Because one will do side reaction, the other one will not. We can process symmetry of reagents. There are all kinds of different filters, metchem, properties, similarity, substructure, and so forth. Obviously, since we are doing chemistry-based design, the software can compute synthesis cost, synthesis timeline, and so forth. All can be used as a filter. This will improve overall in the long term very significantly, obviously. So we're trying to develop a starting point, but which is already effective. But you can imagine that theoretically, the combined knowledge of the chemistry community can really create something valuable here. So a couple of use cases, what you can do with this. In our opinion, you can actually apply this in any design task where you need to come up with a new structure or a new analog. But I assembled 4 of these as an example. So in lead optimization, you have a lead series, a bunch of analogs, intermediates, starting materials. Very often you design new molecules based on SAR and stuff, and you design 20, 30, 40 structures per cycle. But potentially all these intermediate starting materials can actually give you very different structures which answer the same medicinal chemistry question much faster, much quicker, and potentially even better. But you don't think about potentially all these structures. So there is one module where you can load all these intermediates. You can do a substructure filters, things you want to see, you want to have, so limit your outcome. You have a module where you can load substructures which you don't want to have. Another one where you can load similar compounds. So the product should be similar to your best analogs, for example. All these are filters with AND and OR functions, so you can apply these intelligently. And you have about 30 filters with properties, cost, timeline, availability of reagents, things like that. Very simple, easily understandable by any chemist. And then you just have to press start. Just one slide on what the result viewer will look like, or approximately. This is almost done. A huge table, nothing more, really. All the properties, you can sort by any of them. Each compound, you can actually view up to a few million structures be tested without any problem. Browse, sort, refilter, save, all of these. Synthetic information is included. You can actually have a look at the synthesis via viewer. So it's a synthetic viewer. You can click on any structure and go to e-molecules, check the current prices, which are in the system, obviously, with 1 month delay, but you can check live prices and so forth. There is a refilter module where you can actually refilter your final set and save everything. If you want to do general scaffold design, you can pick this is a different module, you can pick just chemistries, no starting materials here, just pick chemistries, put them in a bin, up to 3 steps, step 1, step 2, step 3. Exact same filters. Here you can design non-flat bicyclic structures, press start, and you get the same sort of outcome with new scaffolds. There's a novelty check feature also in the system, so you can filter against e-molecules, which is in our database, and potentially sure can be a patented structures. How would you want to do maybe a patent busting or a reagent analog design or scaffold hopping? The system can intelligently load starting materials for you for this, things which are good starting materials for scaffold design, bicyclic scaffold design for monocycles, for example. Put in your patented structure, this motif you want to go around, and the substitution pattern you want to have, and press start. That's it. A fourth question, maybe you want to ask, what kind of chemistries can make a bicyclic structure from a monocyclic structure? One module, select the transformation, and press start with the filters and everything. So where is ChemAxon in this? We are using a lot of their tools. Obviously, Marvin.js is the client interaction tool, and you can also work with SD files, web services. We have our synthetic know-how database, the reagent database from e-molecules, and the commercial and the patent filters. ChemAxon provides all these tools for structure checking, property calculations, and whatever our designer thinks should be assembled will be constructed by Reactor. There's a lot of integration possibility in this, which obviously is important for a lot of companies, and we've had talks today and yesterday as well. Structures in, structures out, very easy to integrate. Obviously, we can throw all these structures back to any spreadsheet or other tools. With potential e-notebooks, the software can also provide, other than designing, you can do reactivity check or suggest alternative routes, things like that. And thank you. This is some important dates for us. So we have a demo trial version coming out this summer, and hopefully by spring we can actually release something commercially. Thank you.